So we've done type 1. You guys are pretty good with type 1. Let's do a quick review of type 1, okay? So top of your paper there. If I'm factoring out the greatest common factor, I look at the 2, I look at the 4, and I say, what's their greatest common factor? 2. Then I look at the x squared, and I look at the x with their greatest common factor, x. I reverse distribute 2x times something, got me to 2x squared. What was that something? X. And if you're having trouble seeing what that something is, just do the division by that 2x. 2's are 1, there it is. 2x times something got me that positive 4x. Plus 2, we check it by multiplying that. That's 2x squared plus 4x when I distribute back and it matches. So I got it. Type 1. Yay, only 4 more types to go. All right, here's type 2. What I like about type 2 is there's 2 terms in a type 2. But we need to kind of remember something. Well, I don't understand that. But remember this. We were learning how to multiply polynomials, and I said you have to remember this pattern. If you have A and B right there, the same thing, except one's a plus and one's a minus. Remember what happens when you FOIL? There's your A squared. Now here's the outsides and the insides. You get a minus AB and a plus AB. What's minus AB plus AB? Zero, they're gone. And then you do the last one's minus B squared. So we can remember, if it's really the same values, just the plus and the minus, it's firsts and last. FOIL becomes full. Now, I don't even know how to say it, full. So like if I multiply this, x and 3, that's the same. Plus and a minus, it's just going to be x squared minus 9, right? What about this next one? 2x minus 5, 2x plus 5, what's that? 4x what? What's x times x? 4x squared. Good. Okay, multiply. So that's easy, right? When you see them like this. Well, we're going to work backwards now. So if you start with this, how did I get there? Like, how do you work backwards? Let's just do it with this example. Yeah, Ryan, how do you work backwards? And I'm just looking at this one.
You want to take 1x in each parenthesis.
So basically, open the 2 parentheses. You take the square root of this, right? What's the square root of x squared? And what's the square root of 9? And then a plus and a minus? Or a minus and a plus, does not matter. Like this one. How do you work backwards? Well, I know it's, I like you said open the 2 parentheses. Square root of 4x squared. 2x, goes both places. Square root 25, goes both places. Plus minus, or minus plus. So if I want to factor x squared minus 16, what's that? X and x, right? Square root 16, or plus minus. That is type 2. That's it. It's easy. Now, how do you recognize this pattern, though? So you have to know you have this pattern. What I like about type 2 has 2 terms, a perfect square minus a perfect square. If you see a perfect square minus a perfect square, factors to that. Simple, right? Pretty easy. What did I think? I don't know what I got here. Yeah, I'm just thinking, these are the words. So you might hear it be called the difference of perfect squares, something different, special product. I look for perfect square minus perfect square. So I believe I have some examples here. Is this a perfect square minus a perfect square? That's just like the one we just did, except to have y's instead of x's. What does this factor to? What? Yeah. Square root of y squared is y. Square root of 16 is 4 plus minus. What if you did this? Y minus 4. Is that okay? Sure. Right? These are equivalent. It's the unit property. How about this guy? Perfect square minus perfect square? Yes. So what is it going to factor to? Is this a perfect square minus a perfect square? Yes. So what's that going to factor to? 2x and 2x. Right? Be careful, right? Because 2x times 2x gives me 4x squared. I have got a reverse FOIL in here. And then what is the square root of 25? And so plus minus or minus plus mu And I think on your paper I wrote it's dance. What's so dance about that? Why, yeah, what is that?
It's x squared plus 4, x squared minus
Yeah, it's easy. Why is that so easy? Perfect square minus a perfect square. What's the square root of x to the fourth? X squared. And look, x squared times x squared. Now here's the trick of it. You're not done with this one, Ron. I'm not done.
You gotta do it again.
I gotta do it again? Where? What do you mean? What do you think, Greta? Well, okay, this one, is this the pattern? Is this a perfect square minus a perfect square? No. But is this a perfect square minus a perfect square? Yes. So when you are factoring, you don't stop until you can't factor anymore. Now this one, I can't factor it anymore. Well, what about the other one? What does it factor to, Brenna? Well, be careful, be careful. So I take the square root of that one, take the square root of that one. 2 plus 2 minus 2. Because remember how that works? You take the square root, you take the square root, multiply back, right? X squared minus 4. I did that before. This one is not a minus. My pattern is perfect square minus perfect square. This, I don't have it. This can't be factored actually. But this can. So when you are factoring, that's a rule. You factor till you can't factor anymore. Just keep going. Now these are all prime polynomials. Now I'm done. So this is kind of like when you factor, you're factoring 12, right? And then you do 2 and 6, and this can still be factored, so you keep going. Same kind of idea. Same kind of thing. So I know. Alrighty, now the key tricky thing here, type 1 factoring enters into the picture with any more factoring that we do. And what do I mean by that? The first thing you ever do when you are sitting down to factor is say, is there a type 1 situation? Is there a greatest common factor? And you do that first. Now look at this. How come it says this word here? Why do you think that? It's red with all kinds of exclamation points.
It's important.
Yes! And if you look on the middle of your paper there, right above that middle punch hole, see where it says important?
Yeah.
So you might want to put a box around that. You must factor out any common factors first before you begin looking. Is this a type 2 or some of the other types we learned? Now, what are this? Stars. Oh my goodness. It's important. Because look at this example. 3x squared minus 27. Is there a greatest common factor? 3. Alright, well what happens when I factor out 3? What do I get? X squared here, right? Minus 9? Because you're dividing by 3, right? And see what happens here. Yeah, we're nice. So what happens here? Now my algebra teacher, who was awesome, nobody ever asked about, see who's up there? He's the guy all the way on the left after keeps on the carry on. That's Mr. Mandel. He said, when you see a perfect square minus a perfect square, he used to call them bell ringers. Okay? And he didn't mean the thing you walk in the room like a warm-up. He meant, a bell should ring in your head when you see a perfect square minus a perfect square, like jolt. Oh, wait a second. Type 2. Now the 3 is a factor. It stays here. But then I factor this guy. X plus 3, x minus 3. Now I didn't realize I could even do that until I factored out the 3. Because is this a perfect square minus a perfect square? No. But when you factor out the 3, you can see it. So always look for a common factor. Look at this guy. Is there a common factor? 4. Because there's a 4 in here and a 4 in here. What do you get when you factor out 4? And divide this by 4. What do you get? Yes. There's a bell ringing in your head right now. Do I have a perfect square minus a perfect square? I sure do. Well, how do you factor x squared minus 4? X plus 4. X plus 2. X minus 2. Remember, you are taking square roots of both of these. You must do that. Is there a perfect square? I'm sorry. Is there a greatest common factor in 8x squared minus 50? No. Yes. 2. Isn't it? Doesn't 2 go into this one? Okay. Let's see, so what's left? I can divide this one by 2 and this one by 2. What do I get? 4x squared minus 25. No, just go to it. I wish I could stop. Make it stop. Why is there a bell ringing in my head? Do I have a perfect square minus a perfect? I do. So I can, yeah. Isn't this a perfect square? What's the square root of 4x squared? 2x. What about 25?
5.
Look at that. How awesome is that? Awesome! Yes,
You get
ma'am.
We just add the step for C to the last C and the first.
What do they do?
We add it in the step, like, then the type 2, then, the type 2 factoring without having to.
I don't know what we're talking
Oh, I
about.
don't know about it.
Yes?
We would.
Oh, we already did 4x squared minus 25, is that what you mean? Yes, we did, so, yeah. Right, it's a multiple of that one. So do you see how important it is to always look for that? You gotta get into that habit. Here, factor this. Is there a greatest common factor? Always the first question. Sometimes the answer is no. Yes. But you should verify it. So you gotta multiply that, multiply that. Sure. Yes. Oh, we're getting to type 3. We are getting to type 3. Love type 3. Real quick though, you try these. And I'm putting up answers if you want to check part 2. Look for the greatest common factor. If there is one, there may not be, but look for it, look for it, look for it. C's a good one. Is there a common factor?
Yes.
How did I know this was divisible by 3? 1 plus 4 is 5, 5 plus 7 is 12, and 12 is divisible by 3. So I divided by 3. You get y squared minus 147 divided by 3 is 49. When I saw y squared minus 49 z squared, bell went off my head. Okay, it's a perfect square minus perfect square. So right, you set it up, and you say, what's the square root of y squared? Y. What's the square root of 49z squared? 7z goes in both places. Plus minus 4 minus plus. I mean, where was the hold up there? I think maybe when you divide it by the 3, yeah, probably so. We got here, or was just how you did this? Make sense? Anybody else? Now, I want to draw your attention to D. Did anybody say perfect square minus perfect square? It is. And so you say it's 2x plus 20, 2x minus 20. Did anybody do that?
Yeah.
It's not wrong. That does factor in. But are those greatest common factors? They do. What's the problem? I can factor them. Remember the rule? You factor 2, you can't stop factoring. Look how this has a common factor. I can take the 2 out. What's left inside? Plus 10. This one also has a common factor of 2. X minus 10. Now these are all being multiplied, right? So I can do 2 times 2. And don't I kind of get there? Oh, this is wrong. This should be a 4. What is wrong? 4x plus 10, x minus 10. Was that your comment? This is wrong because it was. But look at that. So I got back there. You always have to check. Now it's better if you find it first. Yes?
What if you have a binomial plus?
What if I have a perfect square plus a perfect square?
Yeah.
This is not the pattern, and it cannot be factored.
So what did you say?
This is prime. I'm done. There's nothing to factor. X squared plus 4 is prime. This is prime also because all the factors are prime. Well, I mean, the polynomials are prime. That's okay if this number isn't prime. How about this? Do you notice that common factor of 8? This one had a common factor of 12. And once you factor them out, that delta start hanging perfect square minus perfect square. Questions? Questions? What? Let me just have you pause for a bit. Because I can't wait to, because I want to type 3. And I can't wait to get there. I can't wait to get there. Because type 3 is awesome. Now type 3, remember how we're looking for patterns? So type 2 is perfect square minus perfect square. This pattern is, you have a trinomial that looks like x squared plus something x plus a number. So an example is x squared plus 5x plus 6, right? That fits the pattern. The leading coefficient is a 1. Okay, so if it's this pattern, you have type 3. It has 3 terms. That might help you. So here it is, x squared plus 5x plus 6. We're going to be reverse spoiling, right? Because I got here by multiplying 2 binomials, and I got here by FOIL. I want them backwards. Now, when you think about how you get there, right, there's something, I don't even know what these numbers are. But when I did the outside and the inside, there was some adding to get this. And when I got this last thing, I did some multiplying. So you're basically going to say, well, gee, how did I get there? What 2 numbers did I multiply to get here? And then add to get there. Okay? So that's what we're going to be figuring out. And I want to help you kind of move that thought process around. For some people, it's just ruthless here. For the rest of us, we have to think about it. And I've got this on the bottom of your paper, not this particular one, but it's a little X notation here. Up on the top is what you want to multiply to, and up on the bottom is what you want to add to. 2 numbers that multiply to 4, and also add to 4. What 2 numbers are those? 2 and 2, right? 2 times 2, 2 plus 2. Let's try another example. Again, these aren't on your paper. You can copy them if you like. I want to multiply to 12, but add to 7. How are you getting these numbers? Is anybody like, where's this coming from? How are you getting it? What is your brain doing? Because some of us have brains that just go, comes in a cloud, right? Let's slow it down. Kind of 2 ways to approach it. You can think, what 2 numbers add up to 7 and just try them all and see if they multiply to 12. I think it's easier to say, what is a list of numbers? 2 numbers that multiply to 12. Well, 1 and 12 do, right? Now, if you add them, do you get 7? No. Well, it's not that one. 2 and 6. They multiply to 12. When you add them, do you get 7? No. 3 and 4. They multiply to 12. When you add them, do you get 7? Yes. That's the ones I want. This is what your brain is doing when you go like this. Your brain actually did all that. Now, if your brain was like, slow it down. Slow it down for your brain. Okay, let's look at this one now. And I don't want you shouting it out. When you think you know it, raise your hand. 2 numbers that are multiplying to 9, but they're adding to 6. Multiplying to 9, but adding to 6. When you think you can find those 2 numbers, raise your hand. And again, if you're having trouble, think about what 2 numbers multiply to 9. Okay? 3 and 3. Right? Because 1 and 9, they multiply to 9, but they don't have to 6. Yes? They do not have to be the same number. Look at this. They don't. It's just, it happens with these 2. Sometimes they do, sometimes they don't. Good question. All right, this one I think is on the bottom of your paper. When you think you know the answer, you can raise your hand. I want 2 numbers that multiply to 18, but add to 9. And this is where knowing your multiplication table will pay off. If you don't know your multiplication table, it's so hard. This is part of type 3. We need to have the skill to do it. You need the skill. I haven't factored anything yet. You need to know what it is. 2 numbers, they multiply to 18. And if you're having trouble, you got to think, well, how do I get to 18? 1 times 18. 2 times 9, and 3 times 6. And then you add them and say, well, which ones are the ones I want? Which one? 3 and 6. Can I say 6 and 3? Yes. Can I say 3 and 6? Does it matter? Yeah. All right, let's try this one now. You think you know it. 2 numbers, they multiply to 24, but they add to 14. Oh, you have it already, George? What is it? 2 and 12. So her brain is one that works really fast. Her brain said, let's see, is it 1 and 24? No. 2 and 12, they said yes. Maybe you did 3 and 8 and 4 and 6 as well, right? If you know all the ways you can get to 24, then you just add them and see what you get. 30 and 14. Oh, okay, I gotta multiply. You multiply 2 things, and then you add them. What'd you get for them?
3 and 10.
Let's see, and check it, doesn't work. Multiply up, yes, add, yeah, beautiful. All right, now, I have negatives. Whoa, hold the ball game now. So think about this. I am multiplying to a negative number. What do I know about the signs of the 2 numbers? What do I know?
You have to have a negative and a positive.
Right, one has to be positive and one has to be negative. Now wait a second. number, what am I logically really doing? You know what I'm trying to say here, Ben? What? Well, maybe, but what?
Having a bigger negative and a positive.
Maybe, but I heard something from Noah. Isn't it a logical subtraction? When you have like, -2 plus 5, right? Isn't that 3? Subtraction. So you're really looking for now two numbers that multiply to 24. Let's subtract to 5. That is what you're trying to do. Think about it. So we have 1 and 24, is a 2 and 12, is a 3 and 8, is a 4 and 6. Which is it then? 3 and 8. Now the question is, who's positive? Who's negative?
Either one.
Is it either one? Well, let's say I made it this way. Now when I multiply up, do I get -24?
Yeah.
When I add, do I get -5?
Get 5.
So that's not it, right? So who's positive and who's negative? Now, is anybody saying like what? I like there's a couple of people. So when you have a negative number up here, it has to be different signs. That part makes sense, right?
Yeah.
And when you add things of different signs, logically you are subtracting. So when you look at your two numbers, you subtract them. Then you have to decide who's positive and who's negative. The way you know that, if this number is negative, the bigger number is negative. If this number is positive, the bigger number will be positive. You definitely want to work up, you definitely want to work down to make sure you have your signs in the right place. We're going to try it again, okay? So I want to multiply the -15, but add to 14. Now I'm multiplying to a negative, so one has to be positive, one has to be negative. Two numbers multiply to 15, subtract to 14. What do you think there, Gigi? Just give me the two numbers first. We'll deal with the signs later. 1 and 15. Okay, great. Now, which one's positive and which one's negative? This is a positive number. Yeah, Claire? So the 15 is positive. The bigger number matches the sign. See, the bigger number matches the sign. And check it. Believe me, the first few times and even 10, 100, 50, I make this mistake still. So 15 times, okay. Add them. Yes, it matches. Oh, goodness gracious. Now, this case, I'm multiplying to a positive number, but I'm adding to a negative. Now, the only way to get a positive number is they're the same sign, right? They're both positive or both negative. Which is it? Yeah. Well, they have to be negative because when I add, I have to get a negative number. You see it already? Two numbers that multiply to 28, but add to 11. What is it, Ryan? You see what we're doing here? We can't do it. Now, it's going to take practice, believe me. Okay, this is practice. Yes! Okay. So, let's see what's going on here. Here's the steps now. So if I run back to this, and I'm on the back here, right? So it's steps, that's what I'm talking about. I'm on the back, from page 2. I want to factor this. First of all, I have to recognize it's a type 3. Is it a type 3?
Yes.
Yes. How do I know? 3 terms, leading coefficient is 1, x squared plus something, x plus a number. The other thing you have to ask too, is there a greatest common factor? You always have to ask that. No. Okay. I know it's not a type 2 because it's not more than, it's not different squares. So I'm going through all my patterns. All right. First thing you do when you recognize it's a type 3, set these parentheses, right? We have to figure out, we're reverse FOILing. I'm going to figure out what binomial is going on. Now, you always put x and x. Why? Why? Because it's x squared. Remember, I'm reverse FOILing, so the first numbers are these, x times x. It's the only way to get to x squared. All right, now from there, okay, now comes the fun part. What two numbers multiply to that, but add to that? And so you can make this little shape. Remember, the multiply goes on top, and the add goes on the bottom, and now you play that game again. Right, it has it already. What? You shouldn't have it. Okay, here's the question. Awesome. Great question. How do you know? Think about what FOIL is. So if I have x plus a number and x plus another number, So you remember how you get to the middle? You multiply that and you add it to that. You're adding to this. How'd you get this number? You multiply those two numbers. So it's knowing how FOIL works to remember what you multiply to get this, and you're really adding to get that. You add the outsides and the insides to get here. Let's just think about it. Let's just think about it. Now I need two numbers multiplied to 2. Yeah, what? 2 and 1. Okay. What? Wait, you'll see why. Okay, trust me. Yes. The middle term you get by adding. And you get to this last term by multiplying. Now, okay, we're here. So what? What are these two numbers? You know what you do with those two numbers? It's awesome. Put their signs in, and then you just put them here. Yes, you do.
Wow.
Yes, you do. Now, do you want to verify these? Yes. It's easy to make mistakes here. Look how it says in red. Do not skip this step. And I didn't write that on your paper. You should. You see where it says in your step, verify by multiplying? Right, do not skip these letters. Because now I'm going to do that. And watch what happens, my people. How do you know that? So x times x is x squared. X times 1 is x. And 2 times x is 2x. You add them up to get 3x. Oh! Okay, now the 2 times 1, that's that 2. I multiplied. Okay, don't fall over. Wait, she fell over. Okay. You have to smell the salt. She's okay. Her brains just went. Isn't this cool? I love that. Let's try this guy. Let's try this guy and use these little steps here. Middle of page 2. So first I have to recognize, is this a type 3? First question, is there a greatest common factor?
Yeah.
A 1 and 5 and 6? No. No. Is it a difference of squares? Right? Is it a type 2? You may have to try and rule that out. Is it perfect square minus perfect square? No. Is it type 3? Okay. So it says in the rules you draw these, and the only way to get to x squared is x times x. Okay, easy bit. I need two numbers. Multiply to 6, but add to 5. Oh, I need to do what I need to do. That's already there. 3 and 2? Does that work? Let's see. 3 times 2 is 6. 3 plus 2 is 5. Put their signs in. Put them right here. Factory. Let's verify it. Let's make sure. You don't want to skip that. X times x, x squared. X times 2 is 2x plus 3x, that's 5x, plus 6. Yippee yahoo! Not just yippee. What do you think? Easy. I don't know easy, but we can do it. That one is, let's try this one. This one's a little harder. So, okay, I go through. Is there a greatest common factor? No. It's not a type 2, it's a type 3. So I'm going to draw my parentheses. X times x, that gets me here. Okay. Now I got to multiply to 8, but add to -6. So here's the thing where I'm multiplying to a positive, but I'm adding to a negative. Now, what do I know about the signs? They both have to be the same, and they both have to be negative, because I'm adding to a negative. You got it? What'd you get? -4 and -2. He says, let's think about it now. Check it. -4 times -2 is positive 8. And -4 and -2 added together give it a 6. So you have it. Yeah. So I just put it in here. Factor, done. Now let's verify it. You get x squared. And I'll slow this down. You get a -2x. You get a -4x. Multiply the last negative times negative plus 8. Combine your own. X squared minus 6x, that's the outside and inside, right? Combine the oil. X squared minus, we did it! Hey! Yes, ma'am.
When is the greatest common factor?
2. Now, 2 works for 8 and 6, but it doesn't work here. There's like an invisible one up here. Has to work in all 3. Okay, good question. Excellent question. I don't want anybody's brains exploding. Let's try it again. Let's try this again. So we're going to factor this one. This is example C. Alrighty. You draw these two things. X times x is x squared. Two numbers multiplied to -2 And I have to add to negative 1, so I make this little thing here. Now let's see, this is negative, so it must be plus and minus, right? Logical subtraction. So I need two numbers multiplied to negative 2. And I have to add to negative 1 because it's like they're subtracting from 1. What do you think, Noah? Well, I definitely know it's got to be 1 and 2, right? So who's negative, who's positive? See how this is negative? Make your bigger one negative. So now when I add 1 minus 2, what do you get? Minus 1. That must be it. Yes, ma'am.
So when you're looking for the answer, would it say on the one, would it say factor, find the least answer?
Good. We're going to get to that. It's just like the last homework. Factor means turning into a multiply. That's factor.
So what we're doing now is
Factoring. We're turning this thing into a product of other polynomials. Okay? Verify it. X squared minus 2x plus an x is a minus x. Multiply plus 1 minus 2. Same. Alrighty. This one now, two numbers. They have to multiply to negative 15 and add to 2. Now this is a negative, so again, if there's a plus minus going on here, this bottom number is going to be positive, right? Yes?
5 and 3.
5 and 3, so we know those are the two numbers. Who's going to be positive? Who's going to be negative, Verna?
Negative 3 and 5.
How'd you know that?
Okay. 5 minus 3.
It works, right? That's how we know it. It works. Try it both ways. I always say if this is positive, the bigger one's positive, but definitely try it. If you went the other way first, it doesn't work, go the switch it. So this is plus 5 and minus 3. I'm going to do a quick check. X squared minus 3x. Now again, like I'm doing this real fast because I can. So it may take you a little longer at first. The other side benefit of checking that is you're going to get real good at multiplying. You're going to get real good at multiplying as well. To this day, I do that. When I factor in my head now, I do the multiplication back. That's how I do it. So do that. Anybody have a headache yet? Anybody?
My mind is like, my mind is like clear. I'm like,
Are we okay?
I felt so confused. I'm like,
Really? Because I don't know, when I first learned this with Mr. Mandel, I swear my head was just spinning at this point. Anybody else that's spinning? What? Voices? It's not spinning? Because I'm going to give you a tool. I don't know, because I think using this flowchart will help keep your thoughts organized. We'll get to the back of it. Don't worry yet. Okay. Don't worry about the back yet. Okay. So let's go back to what is the point of factoring? Why are we going through this? To solve equations. So, thank you, sir. So look at this. This is kind of the same rules we had on the last page, the last class. Put all terms on one side, 0 on the other, factor it, and use the zero product property. The only difference is we know how to factor in more ways now. So when I see something like this, x squared plus 8x plus 12 equals 0, all the terms are on one side, 0 is on the other, I need to factor it. So I'm going to use my flow chart. Is there a common factor? Look at your flow chart. I'm doing this with you, right? Is there a common factor? No. So what's the next question? Is it a difference of squares? Is it a squared minus b squared? Perfect square? No. So I'm on the no box. Is the coefficient on the x squared a what? Yes. All right. What does it say to do? It's like 3, right? So we make our two parentheses and get equals 0. Don't forget the equals 0. X and x. Oh goodness, I need two numbers. They multiply to 12, but they add to 8. Oh, 2 numbers multiply to 12, add to 8, 2 numbers 12. Let's see, is it 1 and 12? 1, 2, 3. Which is it? 2 and 6, right? Multiply up, add down, so that's a plus 2, and that's a plus 6. Forward. Here we are. Do we understand why I'm here? Okay, what do you do now? What do you do now?
you take the 12.
I want to know when the factors are 0. What are the factors? This times that, right? So I need to know when is x plus 2 0 and when is x plus 6 0. When is x plus 2 0? And how about this one?
Negative 6.
These are the solutions to that equation. See what we're doing here? This is not so different from what we did last class. This is not so different. Okay, this is not so different from what we were doing last class. It's just when you get to the factor stage, we have more tools. Let's look at this guy. X squared plus 3x equals 18. Well, all the terms need to go on one side, 0 on the other. So this 18 needs to be moved over. X squared plus 3x minus 18 equals 0. Everybody with me? Do you know where we are? I feel like some people have tuned out. Tune back in. Tune it back in. Twist the dial. We're back in. Okay? You with me here? Yeah. All right. Is there a greatest common factor?
Yeah.
I don't see one, right? Especially if there's a 1 up here. There probably won't be. Is there a difference of squares?
No.
Perfect square minus no? Is this a 1? Is this a type 3? Yes. So I'm going to factor using my type 3 pattern method. So x times x. Now I need two numbers. They have to multiply to negative 18. That's a 3. Oh, this is negative. So one's a plus and one's a minus, right? Logical subtraction. Oh. So two numbers, they multiply to 18, and that's a 3. You got it? Yeah, what do you think? 4 and 6? Okay, now go 1 and 18. These are my choices. 1 and 18, 2 and 9, 3 and 6. This is the only way I can multiply to 18, right? 6 and 3. So who's positive, who's negative? And let's test it and make sure it works. 6 plus an 8, good. So plus 6 minus 3. And verify that's x squared minus 3x plus 6x is plus 3x minus 18. That's how I do it in my head. You may want to write it out. And then how do I find the solutions now? When does this factor equal 0? When does that factor equal 0? When x plus 6 equals 0, or when x minus 3 equals 0. And that means x is negative 6 or positive 3. Who's following? You are not following. Fantastic. All right, now another way to ask the question, yes.
A.
Yes.
Says x squared plus 8x. So, it looks like you
Did I do this right? Let's multiply that. We multiply that? Okay. So x times x is x squared. X times 6 is 6x. Plus 2 times x is 2x. When is 6x plus 2x? That's a yeses. Plus 2 times x.
So, do you just ignore the x on the
I'm not ignoring it. I'm reverse foiling. And I'm thinking, how did I get the 8 and how did I get the 12? So I'm not ignoring it. The 8 is right here. So that is getting into the problem when I'm saying how did I get 2 and 6. So it's not being ignored, it's just reversing our thought processes, which is kind of hard. Okay? So what does it mean now find the zeros? What does that mean?
same thing?
When is f of x 0? So you just say, take this. I think this one's actually easier because you're always going to have everything on one side and 0 on the other. Like you're never going to be in that situation. Okay, is there a greatest common factor? I don't see it. It's not a difference of squares. This looks like a type 3. So x and x. Now I need two numbers. They're going to multiply to negative 20, and they're going to add to what? 1, right? There's an x there. How many x's? 1x. And this is negative. So one's a plus, one's a minus. Oh, goodness gracious. You know it. What is it?
5 and negative 1.
All right, 5 and negative 4. How do you know who was positive and who was negative?
Because if it would be negative 5 and 4, it would be
You
negative
get negative 1. So you try it both ways. 5 times negative 4, negative 20. Excellent. Plus 5, minus 4. And I do this x squared plus a minus 4x plus a 5x, positive x, minus 20. When is this 0 and when is that one 0? Well, let me see here. When does x plus 5 equal 0? And when does x minus 4 equal 0? When x is negative 5 and 4 is negative. Now, how do you know this is right? Just like anything, if you were to put a negative 6 in here, it should work. You should get 18. If you were to put a 3 in here, you should get 18. Now, ones like this where it says find the zeros, you know another way to check it? Y equals put in the function. X squared plus x, I'm going to put it down here, minus 20. I'm putting it in the y equals, and I'm gonna graph it. I think it should be at negative 5 and 4, is it? 1, 2, 3, 4, negative 5. 1, 2, 3, 4, boom, yay! I found the right zeros. So the calculator is your friend when you're working on these. It's a real good way to verify. Questions? Good. We're up to the U-tries. And I put little asterisks here. You can't practice these enough. I'm real quick at this because I've done at least, I'm going to estimate how many I've done in my lifetime. 8,976 to be done. At least. At least. That's my bottom level. So the more you do this, the easier it gets. So give these a try. In fact, I'll put the answers up so you can see it. But in a way, do you even need the answer key? How do you know if you're right? Verify by multiplying these factors back. You should get up there. So give it a try. And what does that mean? Find the roots. What does that mean? Find the roots. What does that mean, though? Find the solutions to the equation. It is like finding square roots. That's like a square. That also means the same as if I had said find the solution. They mean the same thing. So give this the old college try here. Now, I'm not going to put this summary up there. There's just summaries here on what type 2 is and type 3 is, but it's also on your homework paper. So definitely use the resources, especially this week.